everybody, I'm just basically a kid that reviews stuff. You know, everyone's familiar with the periodic table, but how did it come to what we know today? Well, let's not waste any time. This is what you need to know about the periodic table. Though this may seem corny when you view this, but regardless, let's take a look. Dmitri Mendeleev was best known for arranging the elements based on atomic number that led to the creation of the periodic table. I said the creation of the periodic table. Come on. There we go. Dmitri wasn't really the only person to come up with this idea. In 1789, Antoine Lavoisier actually came up with a grouping of the found elements at the time based on gases, metals, nonmetals, and earths. Nobody would catch on to grouping the elements more thorough until 1860, when a group of scientists over in Germany did come up with a more accurate number for each element's atomic mass. 3 years later, an English chemist by the name of John Newlands did come up with some organized chart, table-ish, graph-like whatever, based on the 56 elements known at the time. And thus we get to the guy that created the periodic table of today, Dmitri Mendeleev. Take a good, long, glaring, admiring look at the table and observe it. Are you really familiar with the table, or do I need to keep going? In fact, I'll let you take a minute to decide while I take a random drink from this bottle of hot sauce. Basing on the fact that you're not so sure about the table, let's look at the fact on how the elements are organized. The periodic table is made up of 7 groups and 18 periods, though the periods aren't really always talked about as much, but more or less talked about as like the main periods. Now what I mean about that is that there's 8 main periods that are more focused on when talking about the periodic table in a normal high school chemistry class. For each of these elements, they're based on 3 types of metals: metals, nonmetals, and metalloids. The basics of the metals are as follows. They're malleable, good conductors of electricity and heat, and they are ductile. Nonmetals are basically the opposites. Metalloids are basically a mix of both, and is usually set as like and or, and what I mean by this is that they can be malleable but not really good conductors of heat and electricity. Everything varies on as goes basing on the element. Now notice the table. Look at each element box and tell me they're all the same. What I mean by that is look at the mass number and atomic number. The atomic number, in which how the table is organized, is different. So is its mass number, since each element is, well, different. Okay, enough of going off the deep end. Enough of the small talk. Let's get into something more technical to what we should be talking about. The atomic radius of an atom is, well, its radius, an indication of its volume. As shown here, the atomic radius increases when going left to right across the periodic table, and increases as you move down. It increases when moving left to right due to stronger attractive forces in the atoms. It also increases when moving downward on the table due to the protons and neutrons increasing, which, while in fourth, increases the energy levels, therefore increasing the atomic radius. Ionization energy is the amount of energy needed to remove an electron. Moving left to right increases its energy, and moving down each group decreases its energy. The elements on the right side, when moving across each period left to right, wants to keep their electrons, which would require more energy to remove them. But elements on the left side would rather give up their electrons, requiring less energy to take them, which can also be known as low ionization energy. Moving downward on each group decreases its energy due to the shielding effect, making it easier to remove those outermost electrons that already have a lot of electrons. An atom's ionic size is when a neutral atom gains or loses an electron. It could either create an anion or a cation, causing its radius to either increase or decrease. Quite simply, the ionic size will decrease when moving left to right across the table, and increase when moving down the table. Boy, aren't you exhausted from learning about everything yet? The electron gativity is an atom's desire to grab another atom's electrons, increasing from left to right across the periods. It increases since elements on the right side only need a few valence electrons to fill, and would rather do so as opposed to elements on the left side, which would rather give away their valence electrons. The electron gativity decreases when moving downward, since elements at the bottom of the table have so many electrons that losing or gaining electrons really isn't a big deal. I hope you enjoyed this lesson of the periodic table and hope you obtained a lot of information from this review. If you're not sure about anything, please go back into the video and make sure you rewatch what you learned. But we're not out of the woods yet. Being a kid that's going to review things isn't likely to end anytime soon. Oh no, we're not done yet. This is just the beginning. So tune in next time to the cuddly date of December 24th. Thanks for watching. Scratchy Records out.